Number 54 is kind of an interesting problem that they put here into this section in 3.7 because as I'm looking at it, you really don't need the chain rule at all on this one. And the reason for that is because you do have a composition function up here in the numerator, but the derivative within of the x plus 1 is just 1. Now, if that was a 2x plus 1 or a 5x plus 1, this would be more interesting. But as it were, this one's pretty straightforward, I believe, not having done the problem yet, but just looking at it. So here we go. Derivative of y with respect to x. Looks like we're going to use the quotient rule here, everybody, since y is the quotient of two different expressions that both have a variable in there. So let's start off with our denominator, which is just going to be x plus 2 times the derivative of the numerator, which is going to be a 1/2 multiplied by the same base, x plus 1. Drop the power by 1, that'll be a negative 1/2, and the chain rule would say times the derivative within, but again, the derivative of x plus 1 is just equal to 1. So you can get away with ignoring the chain rule here if you wanted. You certainly could put a times 1 there. Probably good to think about that, but not necessary. So that's the first half of your numerator, bottom times derivative of the top, minus the numerator here, which is x plus 1 to the 1/2 power, and then times the derivative of the bottom, which again, that's just a 1 as well, all over your denominator, x plus 2 quantity squared. So that's it for the calculus, everybody. Now let's see what we can do to try to clean this up a little bit. And I see a couple things that could be interesting here. Let's take a look here. So up in the numerator, let's see, the 1/2 and the 1 is just going to give us a 1/2 here. We've got the x plus 2, and then this is interesting now. That is a square root of x plus 1 that would be on the bottom. So maybe something like a complex fraction of 1 times, yeah, all right, x plus 2 over the square root now of the x plus 1. That's a little ugly. And then minus a square root of x plus 1 here all over x plus 2 quantity squared. So that's where I would probably sit with things right now. But my guess would be, not having looked at the solutions manual, let me sneak a peek at this real quick here. I haven't looked at their solution, but I'm pretty sure that's not how they left their answer right there. What I think they probably did is tried to get rid of some of the ugliness, the complex fraction, by multiplying both the numerator and the denominator by the square root of x plus 1. And in fact, I think I'm going to put a 2 there with that as well. And I'll do the same thing down here on the bottom. Now let's talk about why. I'm multiplying the entire numerator now by that 2 root x plus 1. So that's going to get distributed in here. And then in the denominator, not a whole lot else is going to happen. So let's see what that does for us. Now the big payoff to this is that we've just eliminated now this 2 and this square root of x plus 1 by multiplying it by this. So that first term in the numerator is just going to become an x plus 2. And then minus, all right, this times this now, there's going to be a 2 out in front, and the square root of x plus 1 times itself is just going to be x plus 1. That got rid of all the complex fractions now, and our denominator looks like it's going to be a 2, whatever order you want to write this in is fine, x plus 2 quantity squared times the square root of x plus 1. And now at that point, guys, there's a little bit of extra work that I think we can do in the numerator here. I'm going to skip a step. We're going to distribute this negative 2 in there, and let's see what we get. That would be a negative 2x combined with that x right there, so that'll be a negative x. And then, oh, this is convenient, we have a plus 2, and then this becomes a minus 2, so that would cancel. That's your numerator there, guys. Negative x over 2 times x plus 2 quantity squared times the square root of x plus 1. Now, as I'm looking at the solutions manual here, yeah, they've got it written kind of in a factored form, but sure enough, there's a negative x up in the numerator. 2, they have the square root of x plus 1 coming next, and then x plus 2 quantity squared. So that's our answer right there, and I wouldn't be surprised if a lot of you guys did well getting to this point right here, but just weren't quite sure how we got from that spot to the final answer. So this little trick that I did right here, guys, to eliminate the complex fractions might be something you want to file away for the future for how to clean up an answer that's kind of ugly like this one was.